Okay, let's start this movie with the advantages of position tolerances. Okay, this is objective number 8 on your chapter 8 objective sheets. Cite the advantages of position tolerances when compared to coordinate hole location tolerances. Okay, so the biggest thing about positional tolerance is clarity of the requirement. There's only one correct interpretation, and you permit the maximum amount of tolerance acceptable by design. If you used coordinates like, straight plus or minus 20, plus or minus 5.5 thousandths tolerances, okay, for a hole location, what you would end up with is essentially a hole location tolerance zone that was squared off like this. Okay, now if you use a positional tolerance, what you end up with is a circular tolerance zone like this. So essentially, one of the arguments about it, though, is, hey, I can accept, this part here, because it fits in there, because it's actually right at the corner of this square tolerance zone. Now, this part over here is actually at the same distance away from, the true position, but it's not acceptable. And so really, positional tolerances do expand that tolerance zone over a plus or minus tolerance. And then here's the big thing is that their tolerance zones are located relative to reference datums. So let's talk about clarity of this position tolerance. So basic dimension defines the feature's true positions. Freedom and flexibility to meet required level of controls and range of design applications, that helps too. And this positional tolerance is used in all industries, companies, and countries. Okay, so really what we have here is again, they're talking about the distance between acceptable and rejectable positions, and a square tolerance zone used by coordinate tolerances, and then the round tolerance zone is used by positional tolerances. And really what this calculation over here tells you is that we've actually picked up a lot of area in this extra area in using positional tolerances. Okay, here's the biggest part of of um, of this. You really end up with some ambiguity if you don't use positional tolerances. If you're using the coordinate locations like we're showing here, plus or minus 10 for these hole positions and stuff like that, you're really not going to get what you need. It's unclear requirement to force assumptions. Possible tolerance accumulation on subject to multiple interpretations. You can end up with incorrectly produced parts that lead to disagreements that cause production delays and lost profits. Okay, so let's explore this slide a little bit better. Okay, so we have all of these tolerances here. They're specified as these plus or minus tolerances. This is coordinate location tolerances. So let's say what I'm going to do when I go to inspect that part. Okay, I'm going to take like a vernier caliper or dial caliper or something like that, and I'm going to measure from the edge of the part to the edge of the hole, and then what I'll do is add to it half the diameter of the hole to be able to get what that dimension is. But if you look at this, I'm not taking that measurement relative to a coordinate frame. I mean, there's no datum coordinate frame that I'm measuring it to. I'm measuring it from this one location here. And as illustrated in this cartoon here, you can see that maybe it's not the exact position. So how do I really know where I'm at? And then when I start checking between hole to hole, I'm going to use my calipers and I'm going to check from here to here, and I'm going to add to that a diameter to try to get what this hole location is. But how do I know I'm really squared to the datum reference frame? I don't. So really what happens is, you can dimension stuff like this, but it's not a given that you're going to get what you want. Because you're not really inspecting the parts to how they function. You're just inspecting the parts as best you can. Okay, you can't really check the parts, because what we're illustrating here is that there's a lot of ambiguity there. And again, here's the clarity of positional tolerances. Here's what, when I got this 12 thousandths, I got the MMC. I can build a functional gauge. Okay, I can build a functional gauge that picks up these datum reference planes, and I could have pins in it, you know, and I can put the part on there, and I could set the part right on datum A, and I can touch the whole entire surface of datum C and then datum B. That's what I'm showing here for datum B and here. And so I got a true and accurate check of how this part has been made, and not this ambiguity of where these holes are at. I mean, you could check this all day and I don't think you'll ever figure out exactly where you're at, especially if you have imperfect surfaces like this. I mean, if everything's made to perfect form, it's probably okay, but you know, things aren't perfect in the manufacturing world. So coordinate tolerances are bad. Positional tolerances provide clarity to make the parts correct. Okay, I spent a lot of time on that one. Okay, additional tolerances. Let's talk a little about bonus tolerances. This one goes back to the calculations we had before. When you compare the round tolerance zone to the square tolerance zone, the actual tolerance zone increased by 57% once you pick up all of those corners. And what I'm talking about there is these corners right here. Okay, so I'm picking up 57% more tolerance zone. It further increased to obtain additional tolerance from MMC or LMC. Yeah, if I have bonus tolerances, I can pick up more. And increases the acceptability amount of location variation, and increases producibility and reduces costs. Advantages are only achieved by using these positional tolerances. Okay, let's talk about counterbore holes. The counterbore may be machined in a different setup than the hole. Okay, so you come in there and you drill a hole, and then you can come back later with another tool and then drill a counterbore. You know, you position the part underneath the tool to do that. Was it perfectly positioned in both cases? Not necessarily. And there's going to be like 3 different methods for tolerancing a counterbore location with respect to a hole. And that's one position tolerance to control the hole in the counterbore. Or you could do it with separate position tolerances for the hole and the counterbore. Or you can reference the counterbore position tolerance back to the hole location. And let's explore all 3 of these methods individually. Okay, so let's look at the first one position tolerance. Okay, so here we would have a counterbore hole. We have 4x. The size 250 plus 5 minus nothing, and then we have our counterbore and the counterbore diameter and the depth over top of it, and then we have one feature control frame. Okay, so really what happens with this is you can have the same feature control frame applies to both holes, so these holes can be off to each other by up to what's in this feature control frame. So a single position tolerance feature control frame next to the hole and the counterbore callout indicates the same position tolerance applies to both counterbore and hole. And these features act independently and may vary in opposite directions within the zone. Virtual condition boundaries for the hole and the counterbore would be if the MMC modifier is included. So you can have these holes shift off with respect to each other in different directions. Now, but what if we use separate position tolerances? Okay, so separate position tolerance for the hole and counterbore, different diameter tolerance zones desired for the 2 features. The features act independently and may travel to opposite sides of the respective tolerance zone. And then there's going to be virtual conditions if an MMC modifier is included. Okay, so what we have here is we're controlling the counterbore to one position tolerance within the same datum reference frame, and to the other one. And here's the last way to do this. We can apply the counterbore tolerance individually to each hole. So what we've done here is we've established our hole size, the 250 plus 5 minus nothing, with our 22 thousandths MMC tolerance to A, B, and C. And then we define that hole as D. Okay, and then now we specify our counter bore to 375 diameter, 25 thousandths deep, 250 thousandths deep, and we're dimensioning it on a tolerance back to D. Okay, so in this feature, what we're doing is saying, and we're doing these individually. Okay, so each one of these holes here would be controlled by this tolerance. All four of them will be controlled by this tolerance, but within each one of those holes, the counter bore is controlled to that individually. Okay, I'm going to start with application to threads on the next slide. Thank you.